This is the final tutorial in the Begin Python course. We're going to be talking about how to create a plot and visualize data in Python. So we have plt.plot x comma y. This is going to be the basic type of plot that we're going to create, although there are many others that you can create with matplotlib. Let's go to some of the files that we have. This is the 12th one in the series, and here are the other Jupyter notebooks. I'll include the link in the video. And a plot is a visual representation of the data, and especially valuable to analyze data graphically. So data visualization, especially when you have large amounts of data, you don't want to just look at numbers, but you want to be able to see it graphically and be able to compare and analyze it. You can plot with the matplotlib package, although there are others as well. In the incubator example, we're going to want to see how the temperature changes with time, and the x-axis could be the time and y-axis may be the data. So we're going to use the incubator graphs for have a number of different things that we're going to look at, heater, percentage, temperature, and more. Alright, so the basic code for creating a plot is plt.plot, and then you put in your x data and your y data, and then you could also change the appearance of the line. This would be a red dashed line. Alright, so we also have basic Python knowledge right here, and we have underneath the equations we have some things for matplotlib plotting. Here are the different characters for colors, different colors that you might want to see, and then also some for markers, different types of markers that are available, and that comes from the documentation. There are also some different line styles. So we'll show how to change the appearance of the plots, especially when you have multiple things that you're plotting on the same figure. Alright, let's go ahead and just create a sample plot here. We need to import matplotlib.pyplot, and we're going to shorten that as plt. Okay, the next thing that we need to do, this is just in Jupyter Notebook, is matplotlib inline, just to be able to show the plot in the web browser instead of having it pop out as a separate window or just be a hidden figure window. Okay, this line may go away in the future as they figure out ways to not have you do that, but if you type this in with other things other than IPython notebooks, then you're going to get an error there. Okay, so it's just the %, and then we have matplotlib inline. Alright, let's go ahead and create some data. I'm just going to do 1, 2, 3, 4 as a list, and these might be the times that we want to see the data, and then let's create another one, 3, 4, 2, 6, and here's a list with some data. Let's create another one as well. There's another list. Let's plot this. So we have x comma y. Alright, and then x comma z. We're going to make that a red dashed line. And then we'll show, we especially need this not necessarily in Jupyter Notebook, but for other environments where you have to do the plt.show to actually have it pop up the window. Alright, let's go ahead and run this now, and it will run and create the new plots. You can see the default here is blue, but we could change that to something like a black dotted line. Alright, and if we wanted to make it with circles instead, or we can change the appearance in many other ways. So for example, line width equals 5. We can make that much thicker. Alright, so many different ways to modify the plot, but the basic thing is just you have to have the x and y data here at the beginning. And then all of these are optional arguments that you can change to modify the appearance of your trends. One of the other things that helps is the help command. I'm just going to do plt.plotHelp, and this will show additional things on the plotting. Okay, additional examples where you can see some of the additional information, other options in the plot function. Alright, so I'm going to show some of the most common ones. These are many different ones right here. The other thing I really like is that matplotlib has very good documentation online. So if you're looking for examples, you can go to matplotlib.org and take a look at examples, and it will show you all sorts of different plots that you can create. So let's just do a histogram, for example, and it will show you the source for this. Okay, and then it will give you the example plots. So sometimes what you want to do is, if it isn't just a basic plot, you can come here to these examples and just find one that you need it to be similar to, and then you can take that source code and then modify it for your particular application. But many different types of plots here and analyses, it's a very powerful, very good package, although there are others as well. Alright, let's get back down to the activity now. We want to make a plot using 3 lines and 5 data points each. Here's some of the data that we have, and we're going to use this data to plot time, x, y, and z. And so here's all the data that we're going to start with. Don't forget to do matplotlib inline, although you only really need to do this once every time you run Jupyter Notebook. I like to put it in each cell where I'm importing matplotlib and using it, just in case I restart the kernel and only run that cell. Okay, so let's go ahead and just start with plt.plot. We'll just do the basic one here. Okay, and y and z, and if I just run it now, it will show me the plot. If I'm in other environments, don't forget to do the show. This is optional. Okay, and you can see it automatically created different colors for the different plots. But we don't know which ones are X, Y, and Z. So let's go ahead and just change these. I'm going to do a red dashed line here, and then I'll do a blue dot dash, and then let's do a black dotted line. Okay, we do that again. It's a little bit easier to see, but again, I have to look at these and then look at this to be able to distinguish which ones they are. So let's go ahead and add a few other things, and this gets into kind of the next section where we're going to add some things to make the plot more readable. Okay, so for example, label, I can add a label of X here, label of Y, and a label of Z, and then down here I can do plt.legend, and then it'll put a legend in here for me. Alright, and I can also specify the location, upper right, upper left, lower left, and lower right, or by default it's going to do best. Okay, so they're figured out where some white space was and then just put it there. Alright, so there's other things that we're going to want to add to our plot as well, such as an X label, Y label, title, and then we just showed legend. We can also modify the Y limits and the X limits as well. be able to scale some of those. The other thing that's really nice is subplots. We can include subplots of the data. Okay, and you do that by saying I want 2 rows, 1 column, and then I want to start plotting on the very first one. 2 rows, 1 column. These numbers will stay the same, and then you just increment this number to be able to plot the next value. Okay, we can also export plots as well. Let me go back up and let's go ahead and do this other one. We're just going to modify this with some subplots. Subplot. Okay, let's do 3, 1, 1, and then we'll do 3, 1, 2 and 3, 1, 3. Okay, and we need to include the legend for each of those. So I'm going to break this into subplots now, where we can see X, Y, and Z all on separate subplots. Okay, and then we want to maybe also adjust the figure size. I'll do plt.figure, and then fig size equals, I'll do 12 by 8. Okay, it makes it a little bit bigger. You can see that some of the numbers down here were running into the other subplot. And then let's add an X label at the bottom. And I'll just say that is time. I'll make this just a little bit smaller so we can see it all on the screen. Okay, and then let's see, Y labels. We can also add some Y labels. Okay, and you can do that for each subplot if you'd like. And you can add a title or other things with the plot. Alright, so there is the customization. It makes it a little bit more readable. It's easier to distinguish which are X, Y, and Z. And maybe we want to change the Y limits for each of them so that they're on the same scale. So let's just do that one as well. plt.ylim 0 to 10, and just copy it for the others as well. Okay, and run that again so it's a little bit easier to see. Compare the 3 when they are all on the same Y limit scale. It looks like I should have made that just a little bit less there, back down to the negative numbers. Alright, customizing, we've covered that. Now we can export as well. So once you've created a great plot, you want to export it. There are some things that we can do to export as a movie, for example, like an MP4, or most commonly with a static figure, it's going to be able to create something like a PNG or JPEG, or something that you could embed into a presentation, or email attaches an attachment to somebody where you're trying to show them some data and you want to be able to show them a plot of that data. This is an example of an animation that was created with the temperature control lab. It shows the Q1 and Q2 heater values trying to reach particular set targets, which are the dashed lines. So trying to do that for temperature 1 and also for temperature 2. And you can see the heater values as they progress in time and how they are changing to be able to meet that set point target. Okay, we're not going to do anything super advanced like that, although later on you'll be able to see how to do that for your plot as well. Alright, so the basic way to save your plot is just do plt.savefig. And you just can change the type of file by changing the extension. So PNG, JPG, if you're in LaTeX and you are publishing the figures, you want to do it as .eps. And you can then embed encapsulated PostScript file into your document, which will maintain very high resolution the fonts. Okay, but I'm going to go up and let's just export this. Okay, here's our plot that we have. We want to do this before we do the show. Okay, and I'll just say filename.png, although I can change this to whatever figure I would like. Okay, so it saved it, but now we have to go find that figure. Sometimes can be, you forget where you opened the Python notebook or something like that, but it should be in your run directory where you opened your Python notebook. If you have trouble figuring out where that is, we can get the current working directory, which is right here. And I can copy that and just come back up into my, okay, so this is my directory, and then here is my figure right here. It saved it, and you can see the PNG figure right here. All right, and then you can do other things. You know, when you save this, one of the nice things is you can change the resolution. You can also do transparent equals true to make it so that you don't have a white background, you have a transparent background. Let me just try this again. Okay, so let's go back into this directory. All right, and I'm going to copy it onto this blue background. Oh, that did not work for transparent. Maybe it's lowercase transparent. Let me try that again. Okay, saved it again. Let's try this one more time. Okay, there you can see it's transparent background. It's a little bit hard to see there in the image, but it's a transparent background now. All right, let's see. So those are some of the options for plotting. Let me come back here and just let's do the exercise now. After we've learned how to export it, okay, and modify the figure to make it more readable. Now we want to adjust the code below to add a title, X label, and Y label, and we'll adjust the Y range to be between -1 and 1.2. And we'll adjust the X range to be between 0 and 6, and then we'll include a legend, and we'll get that from the label. Okay, it'll create the legend. And then if we want to do a little bit extra, we'll split the two plots into two subplots. All right, so let's go ahead and just put a title here, my plot. Okay, we already have a label right here, and this one is going to be Z. All right, and I'll include the legend right here. Let's say I want to do location equals 2. All right, and then we want to do some adjustments here. Y range between -1 and 1.2. All right, I'll just run this. Let's see how it's looking right now. Okay, and then X limit, I'm going to change that between 0 and 6. Okay, extend it out just a little bit further. All right, and then let's change the Y label. These might be values, and then the X label could be something like time. Okay, so we've modified this. Let's also split into two subplots now. You'll notice with these subplots it doesn't do 0 index, it does 1 index. It's just very similar to MATLAB. So I think matplotlib was trying to emulate a lot of the same things that MATLAB uses, and so that is 1 index based. And then what we need to do is just copy the legend. All right, and then copy these as well, because now when we break it into subplots, it's going to use its own scaling. So we just need to copy some of the things that we had used from before. Okay, but we just want time here on the bottom. We wouldn't want time here because it's going to cover it up with the second subplot. All right, so here we have the plot that, let's see if there's anything else that we needed. Okay, so I think that's it on this one. Let's come down to the next one. We want to make a plot that comes from the labs, the temperature control labs temperatures. And we'll have 30 seconds of data, and the code below sets the heater 1 to 70% and heater 2 to 100%. And it collects data for 30 seconds from the lists Tm equals time, T1 equals temperature 1, and T2 equals temperature 2. Alright, so we've initialized the lists here. We're going to append to those right here, run for 30 cycles, and then we'll print out, but then we want to create a plot afterward as well. Alright, so I'm just going to run this just to collect the data first, and then we'll plot it later. Okay, in a cell below, so the data will stick around. We don't need to rerun and generate more data each time. We can just generate the data once, and then in a cell below we can then modify our plot and tweak things, so we don't have to run an additional 30 seconds every time we want to modify our plot. Okay, so the heater is on, and you can see it. It's going to start heating up. I have temperature 1 and temperature 2. Alright, and so it just heated up by a couple degrees after 30 seconds. Now here is our plot, just the beginning of the plot. Alright, so we have T1, and then we want to add a plot for T2 as well. And let's make this a blue line, solid. Alright, so there is temperature 2 and temperature 1. And let's say we wanted to have some points so we could see the data, and then lines that connect them. Alright, and so let's go with a square here, and the round points here. We have the 2. Okay, now let's add some additional things like X label. This is time in seconds, and then our Y label is going to be temperature, and that's going to be degrees Celsius. Okay, we can also embed LaTeX into this. For example, there is a degree symbol, but you can also do LaTeX commands that are encased by the dollar signs, and so I just did a degree symbol right there if I didn't use the ASCII character degree symbol. But you can put any kind of a LaTeX in there by doing a raw, and then you encase it in the dollar signs, and that gives you the ability to do LaTeX in your plots. Alright, so we added temperature 2. Alright, let's go see if we can plot anything else here. Okay, so we have T1, T2, and maybe we want to plot that heater 1 was on for 70 and heater 2 was on for 100. Alright, so let me just add a couple lines, a couple plots here right above it. So this one is going to be subplot 212, and let's add another one right above it. These were the heater values, and I didn't store those, so I'm just going to do TM. I'll do 0 to 29, I believe is where it went up to, or I could do TM -1, grab the very last one from that, and then I'll do comma, and then this was 70, 70, and then I'll do blue dashed line. Alright, so this is going to be, let's see what that was. Come back up here. Okay, heater 1 was 70, heater 2 was 100. So I just want to add those lines. Okay, so this is going to be heater 2. Hold on, let me get back again. Heater 1 was 70, heater 2 is 100. Alright, and do a label, and I'll do Q1. 100. And let me just make these the same color so they correspond just a little bit better. And we'll include a legend as well. Okay, so you can see heater 1, heater 2, and then the two temperatures there as it increased. Okay, so now I think we have enough to go back to our project and add just a little bit more to our final project, and then we can do a final test of our project as well. Alright, so this is the one that we've been working on as we've gone through these different tutorials, and now we have the data that are going to be stored in these arrays, in these lists, and now we can plot them at the end. We can create a plot after we finish. Okay, so let's come back to here and just grab this code because we're going to be reusing a lot of this and just filling in our new values. Okay, so we have matplotlib, pyplot. I'm just going to take these up to the very beginning. Okay, and then we could put this into a cell below it, but let's just run it all together for this one. Okay, and I'm just going to do plt dot figure, and then I'm going to do fig size. Okay, equals 10 by 6. Okay, we'll have our subplot here, but instead of 0 comma tm minus 1, I'm just going to put tm here. I'm going to plot all of the data points. tm, and I'm just storing heater 1. So this is going to be q store. Alright, and this is going to be heater 1 value. I can put in some LaTeX if I'd like with the underscore subscript. And let's see, the next one that I want is the temperature store. And let's just do that as a blue dotted line. And let's label that T_1. Okay, we'll have a legend for each of these, and this one is going to be temperature, but this one up here on the Y label is going to be heater. Alright, that's going to be in percent from 0 to 100. We don't need LaTeX on that, so I can take off the raw. Alright, and then we're going to save, this is going to be our incubator, and then we're going to show it. But let's put our lab close up here before we plot. Alright, so it'll turn off the heaters, and after 10 minutes we're going to display the plot of the data. I'll just put that comment in. Alright, so here is our plot, and we're going to show after 10 minutes, but let's just do 30 seconds initially, and then we can extend it for more. Alright, so here it goes. Here's all of our code for the project, and it's just going to go for 30 seconds, and it's going to ask us what type of egg, and let's go ahead and do frog for this one. And so it's going to set the target temperature at 25 degrees for our incubator. Okay, so we'll see this go for 30 seconds. You see the heater value, which is on to 100%, and it's just storing all of these values in a list. So all of these values are going into a list that then we will plot. Okay, so at the very end of the 30 seconds, you're going to see some of this data, and then we'll go on for a full, okay, we're going to go on for more time as well. Okay, so it would be nice to show here, what is our target temperature, because we're going to be approaching 25 here, and And when we go for 10 minutes, we want to see what is our target and then how did it do in the end. So let's add that one as well. Let's see, our target temperature is, we could add it right here. Just add it as a line. And this could be 0 to TM, and I'm going to go to the very last one. And then let's add our TSP and TSP. Alright, I'm going to add this as a black line, and I'm going to add this, move it before the other one, so the blue line is going to be on top of the black line. So the black line isn't going to obstruct any of the blue points that come through. Alright, and this is going to be our target temperature. Okay, or I can just say target. Alright, and that's going to create the label, and let's go ahead and run this now for 10 minutes and just see how it does. And then I'll pause the video, and then when it's done, we'll be able to see the performance. And so we've you know, on this project, we've done all of the different parts of this using the elements 1 through 12 from the tutorials, and now we're going to just evaluate the final performance of this. Okay, I'll change this, instead of 300, I'm going to do 600. So that's going to go on for 10 minutes and create the plot after we're done. Alright, and while this is running, let's go ahead and just, let's see, let's go for chicken on this one. It's a little higher. Target temperature. Okay, and then let's go back up to the top, and just as this is running, let's read over the objective again. We want to program the temperature control lab to maintain the temperature T1 at 37 degrees Celsius by adjusting the heater Q1. Display the heater level Q1 with an LED indicator as the program is adjusting the temperature. Create a plot of the temperature and heater values over a 10-minute evaluation period. Alright, so when we read that the very first time, it might have felt like a very big project. Now we have all of the different elements, and we've put those together into a single project. So I'm going to just go back down and look at its progress. Okay, so it's making great progress here. Tracking the temperature, we're just going to get it to add one line at a time. But I'm going to pause it, and then we'll come back in just a little bit after the plot is created. Okay, this is continuing to run. You can see the temperature getting down to a certain level. We're going to have the LED just turned on because the heater just went to 100%. Okay, so you can see as the heater turns on or off, the LED is turning on or off. And it looks like the temperature is doing a fairly good job. It's maintaining it maybe within plus or minus 1 degree or 2 degrees of the target temperature. So you can see it's just going up and down a little bit. There's a little bit of a delay between when you turn on or off the temperature and when the temperature starts moving in your desired direction. So for a more advanced topic of how to build a controller, I have a whole nother separate course, which is APMonitor.com/PDC, which is Process Dynamics and Control. And in there we do things like PID controllers and others that are more advanced controllers than just these on-off controllers. Okay, so these are going to be more advanced, and there's even you know, these lab projects that also use the temperature control lab, but for the control of, you know, the process control, to be able to adjust your heater value not just to 0 or 100%, but along the way as well you can adjust it to different fractional values between 0 and 1 control. And this is something called a proportional integral derivative controller, or PID controller. That's beyond the topic of this introductory Python course. I just want to let you know that that's available, and you know, as you're going through this, you know, looking at the performance of it, you know, you're going to have some other ideas of your own about how to improve the temperature control. Okay, so again, here is the TC lab right here. I'm going to just point to the LED that's going to turn on or off as the heater turns on or off. Okay, so you can see it's fairly hot right now. It went almost to 39 degrees. Okay, almost there, about 38.95. And so you can see that it's maybe 2 degrees high on the upper side and 1 degree low on the lower side, just using this simple logic, which is if it goes above the temperature set point, then turn off the heater, and if it goes below the temperature set point, then turn on the heater. Okay, and so you can see again the LED light is on right here. Okay, let's see, 10 minutes is probably almost up. I'll just go ahead and pause it though until we get to the 10-minute window and then look at our plot. Okay, so here is our final plot. It just finished right after I paused it. So here we have the heater values. You can see the initial heat up, and then it was on for just about 10 to 20 seconds at a time. And there you can see the performance of the incubator. The initial temperature rise, and then when it crossed this point right here, we have an if statement. If the temperature is above that target, then it's going to turn off the heater. But you can see that it continues to rise here, and then it falls, and then once it gets below that value, then you turn on the heater again. So this is going to be very similar to what you might see like for a thermostat for a home, although they do something in most thermostats where they put an upper and lower deadband, so you don't have the heater cycling too much and wear out your heater or air conditioner, but you have kind of a comfort zone, and if it gets outside of that comfort zone, then you turn it on or off. Okay, so there we have the project, and the course is now done. We've gone through all of the different modules. We also have saved our incubator.png file right here so that you can evaluate your performance with that saved figure. Okay, well, thanks for joining on this course, and I hope you've enjoyed it. Again, please give us any feedback on the course at support@APMonitor.com.